Okay, so for this problem, you were given two inequalities. The first thing you'd want to do is change to an equation and then graph it. So I changed the inequality to an equals in both cases. You make a t-chart and then plug in for x, get out for y. So if I plug in a 0 for x, I get y equals 0. If I plug in 1, I get negative 2 times 1 is negative 2. Plug in the negative 1, I get positive 2. Do the same for the other equation, and it doesn't matter what you plug in for x, you just have to evaluate and get out for y. Once you've got your points, then you're going to go ahead and graph them. So on the coordinate axes, I'm going to plot the first line. I'll call that line 1, 0, 0, 1, negative 2, and negative 1, positive 2. It's going to be a solid line because there was an equals in the equation. Had there not been an equals, I'd be making a dashed line. Then graph line 2. We'll call this one line 2. So we'll call this one line 1 here. We have the point 0, 1. And let's make it blue. So I've got 0, 1. I've got 1, 4. And I've got negative 1, negative 2. And then connect those dots up with a solid line. Okay, and that's going to be my line 2. So I'm going to go back now to line 1 and determine which side of the graph I need to shade, either below it or above it. And one thing you can do is pick a test point. So I go back to the original inequality that was greater than or equal to negative 2x. Okay, and pick a point that's not on line 1. So I can come over here to, for example, 4, 0. All right, so if I pick my test point as 4, 0, I'm going to let x equal 4, y equals 0, and if this comes up a true inequality, which it does, then I know to shade toward that point. So the black would be shaded on this side of the graph. If it had come up false, then I know to shade the other side of the line. Do the same thing now with the blue line. Pick a test point not on the line, and you can pick 4, 0 again, or you can pick any value you want, but you've got to go back to the original inequality. And so I've got y greater than or equal to 3x plus 1. I'm going to use a test point of, again, 4, 0. And again, it's just some random point that's not on the blue line. Plug the point in for x and y. So your y value is 0 while your x value is 4. And if this is true, I shade toward that point. And it appears it's not going to be true, right? 0 is not greater than or equal to 13, so that's false. Which means I don't shade toward the point, I shade away from it on the other side of the line. So on that one I'm shading in this direction. I'm looking to see where would the blue and the black cross, and that's where my solution will be. So where I have blue and black, it appears is right in here in the middle. And that's the only place that I see the blue shading and the black shading intersect. So that's where my final answer would be, is right there in that piece of pie wedge.